Good evening, Dr. Wong. My name is Shanmugam Rajamani, and I'm a student of Wawasan Open University. My student ID is 0411500316. Today, I'm going to share my arena simulation model. This simulation model is been draft or designed out of a RRH manufacturing. This is a remote radio head manufacturing process flow. Remote radio head manufacturing or the device or the product is been widely used in wireless technologies, and the application is actually that we usually that use the frequency expansions or the modulations to the chipset makers or the mobile makers, and also the certification labs. And we use this for service providers who are largely using this, and also some of the key critical end customers who are using this RRH for their prototypings. And this RRH manufacturing or the products is widely used worldwide, and we are one of the top producer or the suppliers for the worldwide support based on the 6G application, and we are trying to develop and prototypings most of this customer products back to back with our process to make sure that the development works together with the end customers to make sure that we come out fast to the markets, the product launching. And one of this is the RRH products. So I'm going to share the design, and I'm going to run the simulation towards the end of my presentation, where that I would like to go into a two-session mode. The first section will be I'm going to go through the individual sessions and how that I've assigned the modules or the entities. And secondly, I'm going to share the outputs of the results or the records, all the archive data, that how that I run the simulations. And the last category will be I'm going to run the actual simulation here to see that, that's not going to produce any of the errors or any of calculations issues towards of the simulations. So the first is it's a PCA arrival. The PCA arrival here is actually most of the PCA's operations is being done at the contract manufacturers and also at the suppliers level. And most of the circuits is already well tested at customers at the supply sites or at the suppliers to make sure that we minimize the contacts or the task processes at the factory level. And so we have about three contract manufacturers who heavily built this PCA assemblies and also optimizing the tests so that we have a consistent supplies, because the demand of this RRH product is widely needed for worldwide support. So that's the reason that we assign three suppliers or contract manufacturers to supply the PCAs. Second operation, right after the PCA arrival, it moves into a chassis assembly. At chassis assembly, what I have put up here is actually this is a standard type of process, and I put a size delay release, and also the priority I put it as an high one, and I do put up a resource for the chassis assembly resource one, and and the delay type I set it up to triangular, and the units are being measured in minutes, and also the allocation I've set up into a value added, and I also set up the report statistics. I tick the box to make sure that we have the reports. And moving forward, the chassis assembly is actually what it does is it takes the PCAs, they will assemble this into a chassis assembly. And again, these chassis assemblies are pretty much is a kind of a sub-assembly. It's already been built by the suppliers. And the key process that what we are doing is actually we will take in the PCAs, we will do a quick installation to the assembly, the chassis assemblies. And the next process after the completion of the chassis assemblies, it goes into a HLA process. The HLA process, what it denotes as HLA is it's in a high level assembly, whereby this is a mechanical process where they will complete the entire product into one whole look, which means that they will put up the cover and then they will do some sanity check, and the product is ready pretty much to move to the next station. Now at HLA, I've put up the same thing. Is actually the standard. The type is standard, and I have the actions. I've put it up to size delay release, and as captured as a high level, high one, and same thing that assign the resource. This is for the HLA assembly resource, and the delay time is triangular, unit is minutes, and the allocation is actually a value added allocations, and I do a tick to the report statistics. So the detail of all these individual entities or the modules, such like cease, delay, release, the standards, the triangulars, and also some of the key components in the modules, I've well defined in my assignment, the CA2, in detail of all these modules in kind of a detailed process. So I'm not going to run into this simulation presentation, but it is already well explained in my assignments. So the next module is actually is an assign. So assign is actually there are three key categories areas that I've put up the details. The first one is actually to identify the three manufacturing line here, the PCA 1 line, PCA 2, and a PCA 3. Basically, I put up a blue ball, and the second operation is actually a green ball, and the third operation is the red ball, so that when I run the simulation, we should be able to see the consistent of movements from one station to the other station. It denotes whether that's going to be any queuing or it's going to be a smooth process. Now, secondly, is actually on the attributes. I do add in the attribute name as a FT1, and the new exponential is actually it's a 4. And the other attributes is actually is on the entity sequence, and I've set it up the attribute name as entity sequence, and the new value is actually a P1. And moving on with the next process after the assignment 1. I do route this complete product after the mechanical assembly under the HLA1. It moves to the route 1, and from the route 1 it moves into a station. This is the next process that's moving into a final test 1 right after this. So at final test 1, what I've done is actually this is the only test that we have to support all the three product line, and these three product lines are pretty much identical, which I'm going to share in later on. And FT1, what I've done is I've set the type as a standard type, and the actions I put it as a size delay release, and the priority as a medium, and because we want to make sure that there's a sequence take place between the station 1 or the layout 1, layout 2, and also layout 3. And the resource I've set up as a resource 1, and the delay type I put it as an expression, and the units have been measured in minutes, and the allocation again is actually a value added, and expression as station 4, that it moves to the next station is the station 4. So at a station 4 is actually this will be the sole station where every process after the final test has to move on to the station 4. And right after the station 4, this is where that it decide if, assuming that the product is been designed, say the yield is about 50% for this case, and the type is actually a two-way by chance. And what we have done here is actually, or what the product is actually is running today is actually at false is about 50%. The true, sorry, the true is 50%, and the 50% will be moved, the true will be moved into the shipping, and whereas the false of the remaining of the 50% will be moved into a rework 1. And at rework, we do have a type. I've set it up as standard rule, and the action is actually a size delay release, and the priority is medium, and I've assigned some resource to works on the rework 1. Same goes the delay type. I put it into a triangular, and the units are in minutes, and allocation is actually value added allocation. And same things, I've ticked to the report statistics as, you know, a must to see a report. And it moves after the rework 1. We also have a box, a decide make box for the second. This is where that you will cascade the units, either that it moves into a salvage shipping or it moves into a scrap. And at the decide 2, the percentage of yield that we have computed here is about 70%. And the type is actually is a two-way by chance. And at here, the true ones that, you know, the 70% of the parts will move into a salvage shipping, and the remaining is actually it moves into a scrap. We do not pursue for the rework 2. The reason being is that the sensitive of this particular product, because it's quite sensitive in terms of the components. There are a lot of sensitive components that is being used in these RRH products. So we don't encourage to move to the, you know, the up, you know, with the next level of reworks. And we want to make sure that the we maintain the reliability of the products once that is out to the customers, you know, rightfully. So this is basically how that it derives from the start of the process to the end of the process, how it works. And there's another duplication of the second line and also the third line that is taking place. So it is having, it's almost the same level of setup, and the rulings has been done in the sequence mode, whereby that it moves very balancing, it is a line balancing to make sure that there is no queuing or waiting time is taking place, you know, in the individual processes or in the task sequences, which I'm going to show in a short while. So moving on to the next piece is actually, it is the explanation on the statistics data that we have collected. And this is have been taken on the July 29 at about a 1:26:21 second of AM, whereby I've done a replication 1, and this denote is actually the first process is actually is on the time per entity that we can see we have really recorded all the processes, which is starting from the chassis and HLA and also the final test and rework 1. And you can see the sequencing of the averaging time on individual processes or the individual stations is very consistent, where that we don't see much of delay or long waiting queue for this processes. And same thing on the wait time per entity. It is actually, it is showing the average time of individual processes. It's actually that it's consuming very little hours for the individual processes. Moving on to the time per entity. This is the process. This is the total time per entity. We can see is actually is averaging almost about a 1 to 1.2 minutes for the individual processes. So what it denotes is actually this is a fast volume manufacturing, a very quick product, and the human interception is actually is very, very little, and it is more of it's running into a more digitalization modes in all the individual processes. And the accumulated time, we are seeing this is the VA time, this is a value add time. So for the chassis assemblies, we can see that it is taking about 2.3 averagely for almost all the products. Same goes for the HLA is about a average is about 2.2, 2.1, and the final test is actually is accumulation of supporting all the three HLA line. It comes to about 6.7 pretty much, and the rework is about actually is about 3.1829. Whereas if we move on into the process timing, the accumulated time for individual process, this is the accumulation of wait time. We are actually is gathering a very little hours, as what I shared into the earlier data sheets, whereby the time consumed or the waiting time is actually is very minimal hours. And this is the data of the number in value, where the chassis assembly 1 is actually is taking up about 138 units, the chassis assembly 2 is taking about 123 units, and the chassis 3 is taking about 144. So if you accumulate all these three chassis processes or the stations, is accumulating to about 402 units. And same goes for the HLA, HLA2, and HLA3, the same concept, which is actually is accumulating to the 402. Eventually, it goes into one final test station 1, which is about 402 units. And with the 402 units that goes into the final test, the rework obtained was about 192 to go into the rework 1 process. And moving on into the number out, it shows that the same thing like a chassis assembly 1, 2, and 3 sequencing is about 100 over units in average, and HLA to HLA3 is showing almost about same thing as about 100 over units averagely, and also a accumulation on the final test 2 is about 402 that went in, but eventually after the rework, it successfully can make up about 191 units out. And the same thing on the waiting time, or we call it as a queue time. The queue time is showing us is actually is phenomenal, whereby insignificantly it is very low hours. It is only that it's taking about individual processes about a 0.00200. The averagely is about 00, probably 0.004 to 5, whereby it is a very little hours that is taking in the queue. Same goes into the HLA2, whereby we are seeing almost about 0 waiting time is taking place on these HLAs. The only HLA that is having a queue, I should say that it's slightly, in the high side, it is only on the HLA3 because it has to wait for the process 1, process 2, and then queuing. The last one, the HLA3, is supposed to move into the final test. And the rework 1 queue is actually is only about, it's very little hours to make sure that it can compensate, it can support the rest of the input that goes in the rework 1 and process it quickly for the next level of output, or it moves into the scrap disposal. And the other slide is actually showing the number of waiting. That's a very little, the waiting numbers that we can see in the queues. Pretty much it goes sequenced by all the process, chassis, HLAs, and the HLAs are pretty much is almost showing is about 0 as well. And the utilization usage of the resource, we can see that it's pretty consistent between the chassis 1, 2. It is almost generating is almost about 0.3 to 0.1 to 0.3, and same goes for the assemblies, the HLA assemblies, whereby it's taking averagely is about 0.1 to roughly the highest to 0.19. And cumulative on resource 1 that we are using is actually is only about 0.554 basically, and overall rework is only using at about 0.02593. And looking into the resource usage, these are the number busy. Same thing, the touch point here is actually is using a pretty little hours, and these are using almost about a 1 to 1.2 minutes, and drastically that it is not really holding up any kind of a queuing in any of the stations. So I'm going to go quick into the resource or the usage of the number sized in the test run of the replication one, whereby it shows that the values of the chassis one assembly right out to the HLAs pretty much is consistently showing the 402 units, and the rework has undergone is about 192 units. And after the process of a rework one and recheck back again the entire process, the number out successfully was 401. So this is typically the archive data or the statistics data that we have really accumulated throughout the simulation models that have run on the 29th of July. So now I'm going to switch into my arena simulation. Arena simulation is actually is going to show the runs of all the three lines, and it goes with the blue balls, green balls, and also red balls. And you can observe that there is no kind of a hang up, or there is no kind of a queue up or waiting hours that's taking place on this modeling. And I'm going to share now. So I'm going to take about a couple of minutes to run this, doctor, so you can observe the sequence of the simulations that I'm running, which you can see the process that's moving. I'm going to run about a 1 to 2 minutes so that you can see that's no error, that that's in the simulation, or no faults that you can see in these simulations. And pretty much the flow of the entire product from these three particular lines is running quite smooth into the final test one. So the process or the products which is generating, or the simulation that we have here from all these three balls, you can see that it is moving into all the categories, the shipment categories. It is also moving towards the salvage shippings and also scraps very equally based on the setups on the Decide 1 box and also on the Decide 2 boxes as well, which is about 50% and 70% equally. So Dr. Wong, the strength of this particular simulation is actually the process is pretty consistent. It is actually a kind of a picture modeling for a high volume product, and it's also that it's kind of like one of the product that it gives a human a less touch point, and so that it moves into everything is more of a quicker in a digitalization modes, and all those rework process and everything is being tweaked based on the algorithms or test algorithms and verification and quick calibrations, using all those firmware verification, calibration, and also the performance verification as well. And I would like to say is actually one of the weak point here is actually this particular product is kind of new to the markets, and also a new to the manufacturing like us, whereby we are seeing the first attempt of the yield is about 50%, which is pretty gross, and it is only tend to pass after the second attempt, which is where that we are getting the R&D attentions, or the ER, we call them as the engineering responsible person, to look into this and making sure the test sequences, the test algorithms is able to cope up or putting up some interceptions to the final test one, and making sure that before that it goes into the final calibration and verification process, it has to have a matching compensation to the components to make sure that there is no matching issue at the final test, which is causing about a 50% first pass yield loss. and this can be improvised, through a coming up with a pattern or the task sequence processes, to tune the firmwares in such a way that it should be able to give a good conclusion, during the first attempt at the final test itself. So I already run almost about a 3 to 5 minutes. I think it's about 5 minutes, doctor, and we don't see any flaws in the simulation process here. There is no error. So with that, I would like to end my presentation, and the rest of the explanations I've already defined in my CA in detail, and I hope that you will be satisfied with my simulation. So thank you, doctor. Have a good day.